Hello, everyone. Thank you for joining the Aetna session. I just wanted to go over a few housekeeping items before we get started. Please remember to fill out your session surveys in the app under the session after it. Does a lot to help us plan for next year, and your feedback is very valuable. All the PDFs and presentations will be available online on MLW Online in about a month, and you'll all receive an email when those are available. Thank you very much for coming, and without further ado, Michael and Tyler.
Hello, my name is Mike Fillion, Director of Architecture at Aetna, and today we're going to talk about enterprise data hubs. And I just want to share a story with you. Yesterday, several people were talking about data hubs because that was a big conversation, a lot of the presentations, and the value of a data hub and how MarkLogic fits into a data hub. And a question I got back from several people is, why would you want a data hub to begin with? What is the architectural reason? Why is it an architectural pattern that is important? Most people came through legacy IT shops in the last 10, 15, and 20 years. There was no such thing as a data hub as an architectural pattern. There were other things that kind of represented logically what a data hub is. So through the feedback I had from people and just talking to them, I'm going to talk a little bit more about the reasoning for a data hub to begin with. It's wrapped into the presentation, but I think that will help people understand, since we're seeing that there's a lot of value to a data hub, what is the real genesis? What is the reasoning to have a data hub as an architectural pattern to begin with? The second thing I want to start off with is these, the posters up here, they talk about data silos. And I just want to ask, put up your hands if people here feel like data silos in themselves are bad. Okay, a few hands. I personally feel like data silos are perfectly fine. What they do is they represent a distinct business operation or goal, usually stood up by an administrative application. What is bad when you see data silos is when you need to integrate data from a particular application that's a silo to maybe another application that is also a silo. And we're going to talk today why that is a big problem for enterprises. So I want to start out by just describing a little bit of what Aetna's use cases are. Aetna is a healthcare company that I'm sure everybody knows. And we need, like many companies that have old legacy applications, we need to integrate our data between applications. We have member data, claim data, enrollment data. This is your typical healthcare data. We need a high degree of data governance. It is a healthcare company, so data auditability and traceability, the things that we've been talking about in the last 2 days, these are absolute requirements for Aetna. If we don't have those things, auditors come in, lots of bad things happen when you don't have good traceability, don't have good auditability. It frustrates auditors, and it also elongates the time of the audit and the cost to Aetna. So this slide is really meant to depict that how important data is in an enterprise, such as healthcare, Aetna, but really any enterprise. Data is extremely important. It's what basically represents the operation. It's how transactions are instantiated and represented. Each has a meaning. But more importantly, data, for it to be valuable in an enterprise such as Aetna, it needs to be trusted. And we'll talk about all the things that it means to have trusted data. Data also must be really consistent. You can't be getting different answers at from different applications, say, for instance. If a customer gets into one application, queries the data, goes to another application and gets something different, you can imagine that really doesn't look too good. So consistency is important. But also on the consistency end, whatever is shared, say, the back end general ledger, better also match what a customer saw. And if an auditor sees that those things are different, it can be a very, very big problem. And also, data must be timely. This is something that is, standard for large enterprises. So going back to where I started, when you talk about the data hub and the need for that particular architectural pattern, let's look at a world here without a data hub. These are your applications. Say all these applications all had to integrate with each other. This is the mess that you create. It's called tight coupling, application to application. When applications are tightly coupled, if you were to change this application's structure that interfaces to these others, every single one of the rest of these are all impacted. Someone asked me yesterday, well, so what's the big deal? Because point-to-point is quick. You can do it in any project. You can create a point-to-point interface very, very quickly. So what's the problem, and why does this a problem to an enterprise like Aetna, or why does the business care about this? As you can see, it's a huge maintenance issue. Slows you down, very costly. Every time you change any kind of integration point, you have exponential cost and time. So this is the beginning to describing to you why you want the data hub architectural pattern. And we'll talk a little bit about how things evolve towards a data hub in the coming slides. And last thing here, you see the bad tight coupling, redundant code, inconsistent, all those things. Those are our enemies because it's time and cost. So for those who have been in IT for a while, the whole concept of decoupling applications together by some sort of common message model that is shown here is not new. When service buses started coming into the fore in the 90s, this idea of a common message model was proposed to allow for applications to be decoupled from one another. Not a bad idea. Having a common model is a way to decouple applications. You get a lot of value, decoupling, reusable, consistent, lower maintenance cost. Now, if this was the answer, everybody would know this. There would not be data hubs, enterprise data hubs today, as we know it. This would be the answer. And there's reasons why this is not the answer. So if you look at this slide, these are just some of the problems. If you were to stand up an enterprise service bus with a common message model, and that's how you did all the integration between your applications. Data conformance. You can get consistency and reuse, but it can become hard. What we've noticed, a lot of service-oriented architects can put services together without knowing what other services are doing. They're doing the same things. They're trying to conform data. They're trying to match to a model in different ways, so you get inconsistencies. Source data. The problem with this here is each one of these application systems needs to meet SLAs. Hardware, software needs to be beefed up to make sure that it can perform, because each one of these has their own job to do. But then if you're also integrating, meaning people are knocking on these applications' doors, there's SLAs and there's hardware, software type implications that are there. Audit. This becomes a lot harder. If you have a message model and you're dumping integration information to a log, say, that's a nightmare for an auditor, I can tell you. And it's very difficult if you bring in temporal data and other things like that. Data lineage, again, very hard to do. Problems to understand, provenance, lineage, where your data came from, when it came, how it was used, who used it. A lot of these things can be done but with just this model, but it can become very hard. And then the central data cost. If you're doing some conformance here to this model to make it work before you start moving data to other applications, that's got to be done in the central service bus area. And that can weigh down the cost of this central area itself. Generally, Aetna would look at this and say, this really doesn't meet the standards we need, which are fairly absolute when it comes to data governance, which we talked about some of the elements of that. So the one factor that's missing here, that if people haven't guessed yet, that is not in this, is the database. So the story that I tell people is, I've been around IT for a long time, over 30 years, and when the idea of a common message model first came out, and they were talking about service buses, and other people came up with concept of data buses, and so on and so forth, those were all great ideas because it was based on a principle of decoupling applications one from another. So it was a really good, pure idea. But it just wasn't practically possible to implement that idea and workable that could mitigate a lot of the problems that are listed on this page. I've always embraced the idea of a service bus with some sort of data bus to make it perform, going back to the 90s. There was just no technology that was there to allow that to really happen in an easy way. So what does allow that to happen is the database. So on the converse of what we talked about before, data conformance can become much easier. Your source data cost of the amount of hardware and software you might need for the service bus is minimized. The amount of central caching is minimized. Full data lineage, traceability back to raw data is very easy to do. Full data audit capabilities is easy to do. The database is really the central value add, if you will, to get these stood up in an easy, achievable way. Let's put it that way. So then the next thing comes out is, okay, so we think we have it, right? A lot of architects will say, okay, you want a database, right? I'll bite. Let's make that relational. Why not? That's what we're using. That's what everyone's using. So let's put a relational database here. Other people have, over the years, who've tried to make this work, have tried relational databases here. Some of them have been called, not really hubs, but maybe a stage database or something like that, or some sort of integrated operational data store or something. So lots of different names. So the problem here, everybody's been talking about it. If you guys have been to, Mike Bowers just finished up. Building a relational database has got lots of problems. Everybody knows that to really build a model, you have to model it up front. Okay, you have to conceive pretty much everything up front, what your application is going to do. This can be very problematic because businesses don't always know what they want up front. And everybody in this room understands that the business has a concept sometimes, but they don't always understand all the requirements. So what will they do? You guys have probably heard this. The business just says, I want everything then. I can't really tell you what data I want, so just give me everything. Well, that's a big, big problem for this model. That's a lot of time and cost to model it. Everybody knows incremental changes with an RDBMS can be very difficult. The model can be, very rigid. It's just not a good model. So if you were thinking, if anybody was thinking that they could do this with an RDBMS, it would be a fail out of the box. So when you talk about NoSQL, that's really what solves the riddle. And going back to what I was saying before, the whole concept of a service bus underpinned by a data bus, going back to the 90s and how that's all described, could never actually come to fruition because, again, the database was not there. So NoSQL kind of solves this, modeling your data canonically. If you have a database that can do that, then it can fix a lot of the problems that we've talked about here, needing to model the data up front. When you're modeling canonically, the big advantage Aetna sees is you can model based on business priorities, down to the element level. The business says, I know what I want for these 5 elements. You start developing it. You develop those, and no more, no less. If you have 100 elements, no more, no less. There's none of this, I need the whole model to be completely conceived before you start your development. This is extremely important for agility, and I have to tell you a story. I went to a conference about 10 years ago called Agile Data Warehousing. I went to that conference for one reason, just to prove to all of them that you cannot do data warehousing in an agile way. And so I went and I argued with all of those people. And the reason why that argument was right is because when you're doing complicated legacy ETL with RDBMS models, how do you put a little thin stream that means something to the business, out of every sprint? You can try to do it, but then you're regression testing after regression testing, and you're just burning the projects out. Well, the problem with all that, and the reason why you can't do agile data warehousing with the RDBMS and the legacy ETL, it comes down to the data model. If you have this data model, you pretty much have to populate the whole thing. It's hard to just populate it incrementally or in pieces. So it's like an all or nothing. And it really hurts the ability for agility. Why is agility important? Again, business does not always know what they want at the beginning of projects. So what you do, you start out with what they're clear on what they want. You start developing on it. Again, with a canonical model, you can develop pieces down to the element level, add to it later without major problems. Aetna used this model to develop the database that is also known as the data hub that we're talking about. We delivered a whole line of business in 9 months. And the way we were able to do it was the canonical model and the agility that we got as the business developed their requirements. They did not have all the requirements we needed up front. This was a 9-month project. We delivered an entire line of business. You'd say, wow, you sure the business didn't have their requirements up front? They did not. They knew the main theme of what they wanted to try to accomplish, and generally the data they knew was important to do it, but that was it. Without a model like this, we would have been doomed. So getting into some specific use cases that Aetna has is, the overall business needs would be real-time and batch integration, real-time data search, and then architectural principles, which are important: data decoupling, reuse, agile, ACID compliant, consistent data access, the things that we've talked about already. The business use case, healthcare, Medicare, Medicaid type data, commercial insurance type data that we talked about before. Data governance requirements coming in, full auditability, traceability. These are the kinds of things that come into the beginnings of projects at Aetna. So for use case 1, inside the data hub, what does it look like? So this is just a little bit of a snippet of what it would mean to put full data conformance into inside the data hub. So you can see here, provider at a particular location, all of their data, there's some products, here's some specialties from the hospital, here's the address information, and so on. XML is very easy to understand. Hierarchical is the way the human brain works. The business can look at this and they can understand it very well. This information, as it's modeled, provides that decoupling between source applications. So the second use case we have is enterprise search, which is searching through data in a real-time way, developing it in a very quick speed to market, getting good response time, having it be agile as we talked about before, And then we have similar governance requirements and member and provider data. So how this data looks is you have the raw data that we're bringing in. See the provider raw data that is here. And then below it is how we conform the data. So we're semantically enriching the data with conformance. This enhances the searchability. So this is another use case that you can say that the raw data is decorated by the conform data. Now with this is an auditor's dream, because what auditors want is they want to see what came in to the data hub, all right, in exactly the form that it was in the administrative application. And then they want to see what the conformed model might have looked like and the data might have looked like. This gives full traceability, auditability. This is what auditors want. So this is a little bit different use case. Where the prior use case is really you're taking in data. The only requirement there is to take in all this disparate data from all of these applications and put it in a conformed way so it all looks the same. This is very typical to what you would do in the past in, like, let's say, a warehouse when you're trying to conform your data. In this case, you're operationally conforming it in the hub. Now, going back to where we started with this is that's what gives you the decoupling. The two system of record applications that have two different data models, okay, are not going to talk to each other except through point to point unless you have something like this that can decouple it. So what ends up happening is, going back to the analogy of one application feeds 10 others, if all of them are mapped to this common canonical form, and then you change something in the application, the back end is preserved. So it's not point to point anymore, it's decoupled. Now, if it's brand new data, of course, all of the applications that need the new data are going to need to interface that in. But we're not necessarily talking about that. We're talking about what if they change their structure? What if they move stuff around? It's a really bad act to have it be point to point. So the third use case is what Aetna calls operational data triage. So one of the things that kind of came to Aetna's attention when you really think about NoSQL, right away you understand that NoSQL doesn't have any constraints on what that data needs to be before you load it. Okay, so in MarkLogic using MLCP, it's going to take the data in any form that you have it. What does that really mean? If the data is low quality, dirty, missing fields, dates that are incorrect, numbers that have characters in it, whatever this is can be loaded into NoSQL, be loaded into the MarkLogic database. Why is this important? One of the things that a lot of projects have to do, especially when you're integrating with vendors or applications that you don't have a lot of knowledge of, you don't really understand the nature of their data. You don't understand the quality of it. You don't understand cardinality and granularity, a lot of things. So you can use the data hub as a place to basically profile your data. Now, I'll go back and say that try to do that with a relational database. What's going to happen if your data is dirty and you try to load it into a table in a relational database that has any sort of constraints on it? It's not going to load that row. All right. So what that means now is your data profiling has to be done on reports or with files, or you can dumb down the RDBMS and maybe put it in like a bunch of fields that are all like character, which is not very elegant and not a good way to be able to data profile. So one of the use cases that Aetna saw right away was, auditors don't care if it's dirty or not. They want the data how it was. If it's wrong, it's wrong. In fact, auditors get suspicious if you start remediating data, especially outside of the system of record. That's one of the rules. Analytical or hubs or whatever, they shouldn't be remediating data. That drives auditors crazy, because and system of record shouldn't allow it. But a lot of them don't care because they're done with their job, and then now it's the analytics is taking over, and they're saying, whatever you guys want to do to it, go for it. But I've actually seen that turn out to be that eventually these hubs or whatever these applications are doing remediation actually become an extension of the system of record, which is a really bad thing. So the bottom line is the NoSQL gives you a huge upside in loading the data as is, profiling it, understanding what's low quality, passing that back to the administrative system to have it fixed. So this is a key data governance facet that gets solved. So how does this look? So same thing, auditors love raw data, right or wrong, auditors love it. And when they see you messing around with raw data, okay, they get suspicious. Let's keep in mind, auditors, they don't come to a company and like innocent until proven guilty kind of thing. They come in trying to prove that you are not guilty. And when they see you messing around with things, immediately they get suspicious. Like, what are you doing? Why are you doing it? Is there some malfeasance? Did you do this to some advantage to the company? So they like bad data. They don't care. Data is data to them. So in this case, you can see the paid date, that's bogus. The adjusted amount is bogus. Maybe this was something that came from the mainframe. You know, who knows where it came from? Some EBCDIC to ASCII conversion, you know, had a problem, whatever. Auditors like it, raw data. So you can see here, this is dirty data. But also, you see that there's provenance and lineage. Where did it come from? You know, who did the update? When did it come to us? You know, what was the batch, if there's a batch number? You know, going with it. And there's many, many other pieces of information that you can enrich your raw data with. So this is also known as raw data enrichment. So when we talk about traceability, auditability, and all that stuff, what does it really mean? It means you're trying to enrich it with this kind of information. And so again, I'll just point out that loading this data into an RDBMS, it's a non-starter. You're not going to get a paid date that looks like that there, unless you make a character. Okay? You're not going to get an adjusted amount that looks like that, unless, again, you make a character. So you can dumb down your RDBMS to try to take in dirty data, but then you have to anticipate every possible way it can be dirty. So ultimately, if you really want to cover yourself completely, that means you have to make every field character. Try putting indexes up on character fields, by the way, to get performance. So if you want to do a hub and try to bring in dirty data, make it all character, and then query it to try to do reporting on it or serve it up to the service area, be a failure. So when it comes down to choosing technology, as we're pointing out here, NoSQL fits a requirement, which is, you know, agility, being able to organize your data canonically, to be able to work with data that is of low quality, and basically going back to that's what you need to actually make strategic decoupling of administrative applications. So again, you need the database. The database needs to be NoSQL to make it work. And so that is the conclusion of where we're at with Aetna's journey. And again, need a database, you need the NoSQL. Now it just so happens that MarkLogic kind of is the only thing out there that's enterprise ready, which is the reason that Aetna moved towards MarkLogic with ACID compliance and enterprise recoverability and all these things without having to do a lot of code. So when we first saw that, we immediately looked at this as, wow, we can use this for what we call enterprise data integration. and serve that data into our service bus. And Aetna's journey has basically been along those lines, and it's basically become our strategic architecture for what we call our IT value chain, which is starting in the administrative system, moving through data integration, and then back to the back-end analytics. The key to that is the data hub. So going back to where I started, why a data hub? Why is this architectural pattern being talked about so much? It really comes back to decoupling applications and being agile and being able to deal with all sorts of data conditions that you cannot always anticipate. I'm just checking for time here. How are we on time? Good. So we'll have time for questions. Yep.
Hi, I got a question on, for Aetna, how has the mission of the ESB changed, or its purpose, now that you're using MarkLogic? Are you trying to go and even harmonize the two together? Or are you trying to phase out your ESB? What is the strategy?
Well, so it's definitely changed, so it's a really good question. So as I was saying before, without the database, right, you got to do everything here. So any harmonization, conformance is all going to be done here, or it's got to be done in the source. So these sources could theoretically publish it, but most of the time it's going to be done here. And I've seen a lot of service buses become a mess because they're not built with good control. So you have a lot of code doing a lot of very similar things, and they're doing it differently. And so when you go to this model, you can, this whole thing of architectural separation, where you have data consumption down here, data provisioning down here, you can present a conform set of data to the ESB, leaving pure business logic to be up here. So what do I want to do with that data once it's up in the ESB? How am I going to present it back to the business? Okay, so it allows for that level of separation. So you let the database take care of the data side of it. You let the ESB take care of any kind of business logic side of it. I hope that answered the question.
So I want to quickly talk about the use cases that you were explaining, search use case, and then the operational data triage. You want to profile the data. So if I take a step back and look at the technology choices for these two use cases, one competing technology is Hadoop. What made you choose this path versus the Hadoop path?
Yeah. It's an excellent question. Actually, somebody asked me this very question yesterday, and we talked about it last night at dinner. It's actually pretty mind-boggling to me that there are many, many people who think Hadoop is a database still. That all you have to do is just cram your data into the data lake and do a little bit to it, and then goodness will just flow. Hadoop is not a database, as we all know. Okay, it's a file system. Can you do good things with Hadoop? Yes. Do you really want to do those things outside of a database? In my opinion, no. You don't want to can't do this. You cannot meet these use cases. The data integration you cannot meet, absolutely. Possibly you could do some enterprise search. Certainly you can do data triage. What I like about the database for the data triage, you load the data immediately, dirty as it is. The business is querying it the next second, doing whatever they have to do. I don't know if you can do that same thing in Hadoop. Probably not. Okay. On the search, again, as soon as the data comes in the database, you want to be searching on it right away. I'm not going to do real-time search. I'm not even going to try to do real-time search with Hadoop. That's just my opinion, and other people may prove me wrong. And the first use case about storing a canonical form of data to use to integrate applications. Hadoop's not even in the conversation. But it does come around to a bigger question, which is, where is Hadoop's place in this? And I get this question asked to me all the time at Aetna. And Aetna brought in Hadoop at the same time as they brought in MarkLogic. They've kind of been going on parallel courses. So what I explain to people is there is a big difference between data science or data discovery and what we would term as informatics. Informatics being the back end of the IT value chain, where the front end is your administrative systems, and you got your integration, and then your back end is your analytics. Okay, that's the back end of this value chain. To do data discovery, where you're doing predictive modeling, you can just cram data into Hadoop. You could have data science people try to do predictive modeling and discover new things about the data. Okay, you don't need asset compliance for that. You probably don't even need a lot of backup and recovery. You don't really care. Some of your data quality can be there, some of it might not be. Eventually, the data scientists will take all that into account, and they'll do what they need to do. When they're done, that model saying data value A plus B plus C, when all those things are true, it means something. Okay, clinically or fraud or whatever it is, doesn't really matter. That's a spec. That spec goes from the data scientist, gets thrown over the wall to what I call the informatics area, which is a data value chain of IT to take data from information to knowledge. And so Hadoop has its place at a place where you can just go in there and get data in quickly, let data scientists play with it, model it, discover things they didn't know. When they're done, that model becomes a spec for the IT value chain. I know it was a long answer to a short question, but I wanted to put that in context for you.
So Mike, isn't some of it also, whether it's analytical, operational, or both, isn't that some of the kind of things that are examined on use cases? Because I know his question was specific to use case. So
Yeah.
maybe you can talk a little bit about, to the extent you can, the process.
Yeah.
So when the business comes to something, how you guys select the technology.
Yeah, that's a really good question too. One thing that I've noticed in architecture, that when you talk to a lot of business people, they don't necessarily have a good idea of analytics versus operation, analytical data versus operational data. Some business people have come to me and say, why don't you just cram it all into the same database? Why do you even care that it's separated out? Well, the main reason is the use cases are entirely different, so the architecture and solutions are going to be entirely different. So when you look at this, okay, this is all part of the operation. What do you got to do day to day, daily, to actually make your business run? Okay, that has different SLAs, different requirements. What is good to the operation might not be what is good to analytics. Operations are going to look at transactions, process transactions one at a time or whatever it is, mostly. Analytics probably going to look at all transactions. They're going to enrich things. They're going to do different things with that. Operation doesn't necessarily always care about data quality. They care about throughput. On the analytical side, kind of hard to do a lot of analytics if your data is poor. You can allow for it, but it hamstrings you. It disables a lot of things that you're trying to do with predictive models. So what we try to do in architecture at Aetna is have the business understand there's a very hard line between the operation and the analytical side of the coin. For this is all operation. And by the way, the output of this will end up in the analytical systems, whether it's a warehouse or data marts or whatever it is after this that begins the analytical side of the IT value chain.
What were some of the technical challenges that you faced when you moved away from your existing architecture to this new architecture?
Yeah, this question just got asked to me I had a lunch with Fannie Mae. And so this is a massive paradigm shift. I mean, NoSQL to SQL people is the biggest paradigm shift that you can have. Okay, the data is not modeled the same way. The data put into the databases is done differently. The data coming out is all done differently. This whole thing of canonical form is foreign to people, and it's a threat. So one of the biggest challenges Aetna had is when you bring in something like this is major change to them. And some people resisted it because, you know, they were worried about their jobs. You know, what is my job going to become? You know, data modelers especially, they're like, oh, wow, you're not going to need data modelers anymore? No, that's wrong. You actually need data modelers just as much as you needed them before. It's just the output structure is different. It's going to be basically, you know, going into a document, and it's based on class modeling. You're not really doing an ERD, but if you really think about it, you're doing the same data analysis. You have to understand your source data. You have to understand the subject areas, the entities, how they're related. All of that stuff has to be understood. You're just implementing it differently. But it's a very big paradigm shift. Some data modelers just can't figure out hierarchical data versus related. They just look at it and then they have a brain block. But if you really think about it, most of it's the same. I thought you were telling me we had 2 minutes left.
No. So you have relation and lineage and document. Did you entertain using the RDF capability of MarkLogic to actually do the relationship rather than build your own logic around it?
Yeah, it's really a question of timing. I got asked this at lunch as well. Aetna is very, very large company, very, very slow moving. Just to get NoSQL introduced to Aetna was really, the guy who works for me, Igor, is here. It was like a 3-year convince to get through all of the machinations and the people that you had to get to that. So when it came to, you know, semantics, you know, of course, the way I was showing, that's semantics, just not with triples. That came a little bit later in our MarkLogic journey. So we're very interested in it because we think that it can enhance our capabilities, but Aetna and its journey isn't quite there into production.
One more question. So I think you explained 3 use cases pretty good. I'm sure you must be having a lot more use cases. You did a big investment in building this operational data hub. If you can briefly talk about other use cases, are you shutting down any point-to-point real-time integrations because you have invested on this one? Or you still have point-to-point integration and you still foresee having them depending on the use cases that you're dealing with?
I would love to be able to lie to you and say that there are no more point-to-point integrations at Aetna. Of course, that would be a total lie, and I don't think anybody here would believe it. Again, Aetna is a huge enterprise. Yes, we can shut down point-to-points as we put this into place. Okay, but Aetna is very diverse, has many lines of business. Thousands of applications are out there. We're slowly, it is part of our reference state architecture, so it's a slow conversion over to it over time. Now, as far as additional use cases, you heard me talking about before, being a healthcare company, clinical analysis is important to do. We feel like, triples can really enhance our ability to do clinical analysis. Also, fraud, waste, and abuse is another one, it's healthcare. It's, so very interested, on the Aetna side for that. And triples, are a big part, we think, of helping. And by the way, when you talk about clinical analysis or fraud, waste, and abuse, predictive models, what is your goal? Your goal is to increase your probability that something is going to come true or not. Because the big part of a problem when you're doing predictive analysis is weeding out the false positives. So the better that you get at your semantics, the better your probability that whatever you're trying to conclude, okay, whether that's a bad guy or some sort of clinical outcome, is actually true. So we're looking at it as a way to enhance the probability. It's not that Aetna isn't doing these things today, but it's all about enhancing the probability that something's going to be true or not. That is really the essence of how predictive models get refined. You're adding more data points to enhance the probability that something is going to be true.
Mike, just to understand this evolution a little bit to that gentleman's question up there. When you say your reference architecture, you chose MarkLogic because you had a time-bound thing you had to deliver. Not you, but Aetna chose it. Because that's something that do in 9 months. It was a brand new business. So some of the behind the scenes is it developed a new claim platform. This was fully carved out because it was something new. That has evolved to become the, an enterprise reference
Yeah, I mean, when we started out with a project that was prior to the standing up of this new line of business, which was successful. That was enough impetus to convince the business, let's try this for this new line of business. Although it was a pretty big risk to them because they're saying, wow, new technology for a new line of business. But you know, we staked our reputations. We did a lot of due diligence. It was leading up 3 years. I'm one of the hardest people to convince to go to something new because I do a lot of due diligence, but once I am, I'm like behind it. And so I helped the business understand that it really wasn't as risky as that they thought. And in hindsight, if we had tried to do that particular project with an RDBMS hub or some sort of stage database or something in the middle, or try to do all the integrations in the service bus, it would have failed. Absolutely would have failed. So after that succeeded, then the business realized that, wow, okay, we just put this new line of business in 9 months. That ought to be one of the backbones of our reference data architecture.
So Mikey, just the last question is, looking forward, because some of the pressure on this question, what pressures are you getting from the business? Is it new data sources? Is it unstructured data? Is it real time? Because we all know healthcare is predominantly batch. It's trying to get batch to real time. But what are some of the pressures that you're getting from the business to evolve this? Is it any of those areas?
Yeah. Well, all those things, but I mean the key one, we talked about it already, is agility. The business is expecting projects to be delivered much quicker, much faster, much cheaper than they ever have been before. And they saw it happen with the new line of business. That's what they've been asking for the last 20 years. And we have, Aetna IT has not been able to deliver that. We just couldn't. There was no architecture that I knew of that could get data in and through across this value chain easy and cheaply, especially if you have to build something brand new or have to change something in a major way. So the business sees this is an agility play for them. And I don't mean agile in the Scrum sense. I was just talking about, you know, how much time it takes to develop very complicated, you know, projects and how much is the cost, which the business just doesn't have the money. There was a time where it was getting to the point where there wasn't any project that I could architect that the business could afford. That's a pretty bad place as an architect to be.
So basically, I'm going to ask you to go a bit in the future. So there's data that you need to put all centrally to do your analytics, and there's other that you needed to do the reference, but then the details you can always go. What's your position? How do you think Aetna would be around federation, a hot topic right now in data? Because there's so much data, some people are starting to believe it doesn't fit in a single place.
Well, yeah, actually I have a data federation slide. I pulled it out because it's a very, very hot topic. What I will tell you is getting the data from these applications was so easy to do, all right, and it's so cheap to store it, and it does what it needs to do. Federation wasn't something we were going to consider, especially when a lot of these applications are vendor applications, maybe not even at Aetna's site.
Yeah, that's why I asked the future, because when things get easy, remember 20 years ago they said computers, we don't have jobs anymore. Mm-hmm. Actually, we need more programmers now than we did before, so when it gets easier, your data will actually grow. So.
I do have to point out to you, I have a slide, I'm going to find it. I got a slide that's like, I will, let me just end up by saying these problems, many of these are not solved with federation. Most specifically, data audit. Okay, I can't say to Aetna's auditor, hey, go talk to that vendor. They have some logs of everything they sent to us. Or we have some logs, or we can go do that. Well, logs are like really, really bad because, I'll just end with this, guys. I know we're at 0, but this is an important thing when it comes down to auditors and temporal data. I'll give you a perfect use case. An auditor comes in and they say, we want all of your members and these 50 attributes. Dump it out and give it to us. So we do it and they're happy. All right, 3 months later they come back and say, I want you to add 15 more fields to the fields you gave to me. But it has to be as was the date that we got our first data. Try doing that in logs. Try doing that with reports. There is so much baling wire and tape, it is ridiculous. So in federation, you have these kinds of problems because you don't know, most administrative systems, they're not keeping snapshots of their data. They're updating their data, and what it was before is gone. So if you're not keeping it down here, somewhere, it's gone. It's nowhere. It might be in logs, maybe. Some applications might have it in logs or tapes, backups of administrative systems. That's not good for auditors. Really bad. So what I would say back to federation is these problems, you got to look really long and hard at these problems. And does federation solve these problems? And in many ways, federation brings the same problems as point-to-point brings. And IBM and the rest of the world aren't really worried about that. They're just saying put everything into memory. Our business is not going for that, I can tell you.
Michael, thank you so much.
Thank you.
Great session.